everybody, and welcome again to this channel. I remain Mr. Simplicity, and in today's video we are going to be looking at the application of implicit differentiation. Okay, so before us is a question. The question gave us an implicit function and asks us to find the following term. Okay, you can see that. So we want to start solving, starting with the very first one. The very first thing they ask us to find is dy dx. dy dx. So let's see how we get dy dx. So to get dy dx, we follow the process of differentiating implicit function. Okay. So when we differentiate this, we are going to have 2x plus 3y squared dy over dx minus 2 y over dx equal to 0, following our regular differentiation. Then make dy dx stay on the left, so we have x squared dy dx minus 2 dy dx equal to 2x crossover minus 2x. Dy dx now is a common factor, so we have 3y squared minus 2. So this is equal to minus 2x. If we make the dy dx surgery of the formula, we have minus 2x all over 3y squared minus 2. So the first question is answered. Just follow your regular implicit differentiation. Then the second question here says we should find the slope of the differentiation, the slope of tangent line to the curve at the point 2, 1. So what they want is slope of the tangent curve, and the slope of the tangent curve is m equal to dy over dx at 2, 1. That's what the slope of the tangent point simply means. And if I'm going to solve this, it simply means wherever I see x, I put 2. And whenever I see y, I put 1 in my dy dx. So it's a simple substitution problem. So if I should substitute here, I have minus 2 times x is 2 over 3 brackets y is 1 squared minus 2. So if we solve this, minus 2 times 2 is minus 4 over 1 squared is 1 times 3, 3 minus 2, 1. So our answer is minus 4. So we just answered 2 of the question there. First say find the y ds, we've gotten that one. Second say find the slope of the tangent line to the curve at 2, 1. So we solve down. 2, 1 simply means wherever you see x put 2, wherever you see y put 1 in your dy dx. So this is the formula for the slope of the tangent line. Okay, so let's go to the third question. Okay, the third question says we should find the equation of the tangent line to the curve. The first was the slope of the tangent line to the curve. So the equation of the tangent line to the curve uses this formula that says y minus y1 equals to m bracket x minus x1. Okay, so this is the formula that we use to solve this problem. In this case, remember we have a point 2, 1. In this case, this is my x1 and this is my y1. So all I need to do again is substitute. And remember, we already have m to be minus 4 from our second calculation. So if I substitute here, I'm going to have y minus 1 equal to minus 4 bracket x minus 2. So this is y minus 1 minus 4 times x is minus 4x minus 4 times minus 2 is plus 8. I want to make y subject of the formula. So that means y will be equals to minus 4x plus 8. Therefore y is minus 4x. So this is the equation of tangent to the curve at the given point. Okay, it's a straightforward question. All you need to do is to know your formula. If you know your formula and the point is already given, you have gotten the slope of the tangent, just substitute, you get the equation of tangent line to the curve. Okay, so the next question here says we should find the slope of the normal line to the curve. The slope of the normal line to the curve. So the slope of the normal line to the curve, that's the fourth question. It's simply slope, let me write it. Slope of normal is equals to minus 1 over n. That's the formula for the slope of normal. We already know n. So if I substitute, I'm going to have minus 1 over minus 4. So that will give us 1 over 4. So this is the slope of the normal line to the curve. So that question is answered. This is so straightforward, following the steps. Then the final question here says we should find the equation of normal line to the curve at the same point, 2, 1. Okay, so since it's at the same point, it means we are using this as our slope. So the formula says for slope of equation of normal line says y minus y1 also minus 1 over n x minus x1. So we substitute our y1 and y2, and then x1 and y1 rather, x1 and y1. So that will give me y minus 1. And we have calculated all of this to be 1 over 4. 1 over 4 x minus 2 plus multiply 4 bracket y minus 1, or rather, instead of plus multiplying, open up your bracket, you have y minus 1 equals 1 over 4 times x is 1 over 4x. 1 over 4 times minus 2, use your calculator, it will give you minus 1. Make y subject of the formula, you have 1 over 4x minus 1 over 2 plus 1. This is y equals to 1 over 4x minus 1 over 2 plus 1 will give us plus 1 over 2. So this is the equation of normal line to the curve. Okay, so we're going to take another example on this same application of implicit differentiation. So this is another problem on the application of implicit differentiation. So what we need to do as usual is to, this question is so straightforward, they didn't break it down like the previous example. We just say find the equation of tangent and normal to the curve, which is this equation at the point 2, minus 2. So the first thing to do is to take the curve, which is the equation given, and find the y dx. If I do that, I'm going to have x square y square minus 2x equals to 4 minus 4y. Differentiating through, this is product. A product should say leave the second, differentiate the first, plus leave the first, differentiate the second. And the second is y, so we attach the y dx. That's just differentiating the first thing. So if I differentiate 2x, I have 2. If I differentiate 4 is 0. If I differentiate minus 4y, I have minus 4y dx. Okay, let's simplify what we have. Y squared times 2x will give us 2xy squared. X squared plus 2y will give us 2x squared y. Then our dy over dx minus 2 equals to minus 4 dy over dx. Okay, so the next thing now is to make our dy dx stand on the left. So doing that, I'm going to have 2x squared y dy dx. This will cross, we have plus 4 dy dx equal to, these two are coming over, minus 2 cross, you have 2 minus 2xy squared. So at this point, we are going to take the common factor, which is dy dx. So dy over dx into 2x squared y plus 4 equal to 2 minus 2xy squared. So if we make dy dx subject of the formula now, 2 minus 2xy squared over 2x squared y plus 4. If you observe, 2 is common to all the terms. If I bring out 2 at the top, I'm going to have 1 minus xy squared. Right? If I bring out 2 at the denominator, I'm going to have x squared y plus 2. So 2 is gone, leaving us with 1 minus xy squared over x squared y plus 2. So this is the y dx. Remember, they didn't ask us to find the y dx. They asked us to find the equation of tangent and normal to the curve. So now that we've gotten the y dx, it will help us get the slope of tangent and then the equation of tangent. So the slope of tangent is m, and we said it's dy over dx at the given point 2 comma minus 2 in this case. So which means whenever I see x in this equation, I'm going to put 2. The first is my x, the second is my y. Wherever I see y, I'm going to put minus 2. So if we do that, we're going to have 1 minus 2 times minus 2 all squared over 2 squared times minus 2 plus 2. See that? Solving on. Use your calculator or take it on out. Minus 2 squared is 4 times 2 8. 1 minus 8 is minus 7 over 2 squared 4 times minus 2 minus 8. Minus 8 plus 2 is minus 6. So that leaves us with 7 over 6. Since the minus sign will cancel out. So now we have the slope of tangent. The next thing we want to do is to bring in the equation of tangent line. The equation of tangent line says y minus y1 is equals to m into x minus x1. So this will be y minus y1 is minus 2. Okay, then equals to m 7 over 6 bracket x minus x1. X1 is 2. If we simplify this, we have y plus 2 equals to 7 over 6 bracket x minus 2. Okay? So going further from here, open up the bracket on the left, so we have y plus 2 equals to 7 over 6x times 2. If you use your calculator, it will give you minus 7 over 3. So collect like 10. Maybe we want to make the y the x subject of the formula. So that will be y equals to 7 over 6x minus 7 over 3 minus 2. So y equals to 7 over 6x minus 7 over 3 minus 2. What would that give us? That will give us minus 12. Is it 12? 3 times minus 2 is minus 6. That's minus 13 over 3. So this is the equation of tangent. Equation of tangent. This is what we just got. Okay. So to obtain the equation of normal, we use the formula that says y minus y1 equal to minus 1 over n into x minus x1. Look at the two formulas carefully. It's a slight difference, the negative inverse of the slope of tangent. Okay, so that every other parameter is available, we can substitute minus 2 over minus 1 over m. We calculated m to be 7 over 6 into x minus x1, which is 2. So if you solve this, this is y plus 2, isn't it? Y plus 2 equals to negative inverse will give me minus 6 over 7 of x minus 2. So let's see what we have next. So solving further, this is y plus 2 equal to minus 6 over 7 times x will give us minus 6 over 7x. Minus 6 over 7 times minus 2 will give us 12 over plus 12 over 7. Collect like 10, we have y equals, or rather make y subject of the formula, minus 6 over 7x plus 12 over 7 minus 2. So this is minus 6 over 7x. So when you subtract 2, this is 14. That will give you minus 2 over 7. So this is the equation of normal to the curve. So that's the application of implicit function, and you can take your time to go through the two examples I have solved and see how you can work around it. If you have any challenge, as usual, go to the comment section and put it there. I'll be able to reply. Thank you for staying to the end of this video. I truly appreciate it. Please do well to share this video with your friends and colleagues and every other person you know it will benefit. Your contribution helps me stay focused. Thank you and have a blessed day.